So let's talk about the regulation of three key ions. We're going to start with sodium. Okay. So for sodium, the regulation focuses more on the content. Okay. So let's take a look at how this works in terms of the, say, reduced amounts of sodium. So when sodium levels in the body, they go down, it triggers one of the main responders is aldosterone. Does that make sense? Which immediately increases sodium retention in kidneys and the amount of sodium gets restored. Now, one important feature of the sodium is that, as you remember, water follows it, right? So essentially, in some instance, we can say that when sodium levels in the extracellular fluid, well, now, what I'm trying to tell you is that concentration of sodium is maintained at the very, very precise level. So when we say reduced sodium, we don't talk about long-term reduction in the sodium concentration, we're talking about long-term reduction of a sodium content. Does that make sense? Not the concentration, but the overall content. No, yes?
What is the difference?
Okay, so if you have 1 mole per liter, it's going to be 1 mole per liter. But if you have less total amount of sodium, you're going to have less liters. You see what I'm saying? What I'm getting at is when we say sodium in the body goes down, it means the overall amount of sodium goes down together with the overall amount of extracellular fluid. Blood volume decreases. Does that make sense? Concentration remains the same. The amount goes down, the volume goes down, the concentration remains the same. Does that make sense? So, when we say that sodium amount goes down, it immediately means that blood volume is also decreased. When blood volume is decreased, what happens to blood pressure? It's also decreased, yes. And this is your trigger for aldosterone. Does that make sense? Clear? Now, as a matter of fact, I also want to explore with you the balance in terms of, what happens when sodium amount goes up. Okay? So when you consume a meal which contains a lot of sodium, the sodium ends up in your blood. Does that make sense? Now, here's the trick. What did I tell you about the sodium concentration? It is extremely tightly maintained, and actually the process that maintains it is osmosis. So when sodium in the blood goes up, or extracellular fluid, it draws water from the cells, because cells have a lot of it. Okay? So you have in the blood, right? Does that make sense? And what happens when water gets into the blood? Your blood volume goes up and your blood pressure goes up. So this is why if you have a meal which contains a lot of sodium, are you following me? It will immediately bring up your blood pressure. Does that make sense? So, if you are a healthy adult, the elevation of the blood pressure, what it will do? It will stimulate actually it may stimulate two responses. Well, it will stimulate one main response. It will increase the urine production. Does that make sense? Are we clear? Another interesting feature that will result in the increased sodium concentration in the blood. If you think about it, when sodium goes from your super salty meal into the blood, it very transiently, for a short period of time, the concentration actually increases. Does that make sense? I mean, it doesn't. What I'm trying to tell you is that this water gets in the blood not in the blink of an eye. It takes some time. So for some time, the concentration of sodium in the blood will be elevated, which means the osmolality of the blood will be increased. Does anyone remember the hormone that is stimulated, which release is triggered by the increased blood osmolality? And ADH is released. And remember what ADH does? It increases water reabsorption in the collecting ducts. Does that make sense? Which increases the amount of water in the blood. But it also has another interesting feature. It has something to do with how you feel. You start feeling thirsty. Does that make sense? And if you respond to that urge, you will also increase the amount of water in the blood to maintain the concentration of sodium at the proper level. This is what I like about, this whole story about sodium regulation, potassium regulation, because all of your knowledge from endocrine and cardiovascular, they all come together. You see what I'm saying? Now imagine someone is eating constantly high food with a high concentration of sodium. That will lead to permanently elevated blood pressure. Does that make sense? Although, yes, it will, for some time it will be modified by increased urine output. But the problem is, remember our conversation about the filtration membrane in the kidneys? The capillaries, the glomerulus, and the glomerulus surrounded by the podocytes, and the filtration slits, you see them like little serpiginous lines. The filtration slits between the food processes of podocytes are what filters. That makes sense? Now imagine you apply elevated pressure on your filter all the time. It will eventually give in. Does that make sense? So the consumption of food with elevated sodium content may damage the filtration membrane in the kidneys. Does that make sense? On top of that, elevated blood pressure frequently elevated blood pressure will result in the blood vessel remodeling, inflammation, increased risk of atherosclerosis, thrombotic events. Basically, you develop elevated blood pressure as a chronic condition. Make sense? Good? Okay. Okay, so this is the sodium. And think of it this way, actually. Elevated sodium is akin to having a dehydration. You see what I'm saying? So your response to eating something salty is the same as your response to being dehydrated. Because in both cases, you have increased blood osmolality for a short period of time. Okay, good. I think we mentioned potassium regulation before, which is pretty straightforward. So if potassium gets elevated, okay, there are two outcomes. One is direct excretion. So potassium is filtered. And another one is increased levels of aldosterone result in the potassium secretion, specifically secretion. Good so far? Okay, finally, I'm going to say a few words about calcium. Elevated calcium, direct excretion. So here's the problem with, you can't possibly elevate calcium to the amounts that would akin to hypercalcemia. Are you following me? But generally speaking, if you have somehow managed, like, I don't know, you consume enormous amount of dietary supplements that contain calcium, I don't know, 5, 6, 7 grams a day for some reason, you know what I'm talking about? Then your kidneys, they have a capacity, so the filtrate will contain enormous concentration of calcium. Calcium compounds are not particularly soluble in water, not all of them, but many salts aren't soluble. So people with hypercalcemia will start forming precipitates in the kidneys, and that will increase the chances for forming kidney stones. Okay, does that make sense? Now what if your calcium is low? We covered it before. Increased parathyroid hormone results in a decreased excretion. Okay? Now, a little bit I'm going to throw here in the corner. What is the main hormone that regulates, two hormones that regulate water balance? If you are dehydrated, what's going to happen to your blood pressure? It's going to go down. What's going to happen to osmolality? Increase, yes, because you're losing water. So decreased blood pressure will trigger aldosterone, which will increase sodium reuptake, and the water will follow sodium. Does that make sense? And both decreased blood pressure and increased osmolality will trigger increased levels of ADH, which will increase water reuptake. Now, if you look at this, and you look at this, they're very similar. Can you see the similarity? So, the primary, so they are inextricably linked, the sodium and the water. Does that make sense? Because if you increase sodium, it will immediately start drawing the water out. If you increase water, okay, it will go to where sodium is more, so to say, common. Okay, we're cool? One of the examples of what happens if somebody overhydrates. So if you drink a lot of water in a very short period of time, It will dramatically increase blood volume and blood pressure, which lead to leakage in the cerebral vasculature. It will lead to brain edema. On top of that, since the concentration of sodium in the blood suddenly drops, there's a good chance that water will start going into the cells. And the main problem, you see, because the concentration of sodium in the cells becomes kind of higher. And the main problem with that is that it can lead to water physically migrating into places like neurons. And you have swelling of neurons and they stop functioning. There was a famous story in California, there was a competition who will drink most water in a short period of time, and the winner died actually next day. 6 gallons. Okay. So, I don't know if they sued or not. Good? Okay.